std io dot h, and what is that? Let me I write here one of the signature void display, and let me, before that one, can I write the structure here? Struct here node and open bracket, two field here. The two field, one is called the info, and let me, this is the integer type, time limit. We can use different data type here. And the second member or second field of the node structure is called the next, and this is a pointer to the structure type. Pointer to the structure type. Remember that is point. Again, what we'll write here? We'll write here type def struct. We rename. Type def is used to rename data type. Struct node. We'll write here as a node type. That's all. This is about this. Then we'll write the signature here. Void display, and the argument. What is the argument? Actually, this is one type of the function with a no return type with argument. So what is the argument here? I will take the argument is called node style. So this is the idea here. So we will write here integer main, the body. Within these functions, what we are going to do that? We are going to do one after another things here. So what are the things we will do here? We will declare the different pointers, head type, we will declare the temp type or PTR, we will use the PTR here. Similarly, as and when we require, we will go for the declarations of this one. Timing, let it put it here like this. So we don't know how many such things we are going to use here. So the basic knowledge behind this particular programming is that, now what is our idea? We have to, first of all, this is a variable declaration, integer I will use, first of all, let me, as I told you that you create the head node first. Create the head node. So if you are going to create the head node, how will be created this head node here? The head node will be created like this. First of all, I will write node star head and star PTR, create the head node. And when you are creating the head node here, so I will write like this. Generalized idea of creating the head node here. Write here head, and I will write here node star, because we are going to use for dynamic memory allocation. We will use either use malloc function LC or calloc function LC or realloc function LC for allocation of the memory. And similarly, we will go for the deletion. So we will use the free methods on that. And for that, we will use one of the header file, std, we can say that include std library.h, this library. So we will add here has include std library.h. So head node star is equal to, right here, malloc. Here we will allocate the size of the node. That's all about that. This is data type. So size of operator, we can use here the size of operator. We sometimes call it as an operator. We will use this size of operator for doing that to find the size of the node. And what I did here, now you don't have to put the value, but generalize that head of the, because head does not contain any cell, I am going to create one of the head node here. This is the head node, and let me initialize this field is null. So I will write here the null field like this. This is first of all the one. Now we are going to create node. So what is this idea? Now I will write here. I may use PTR here, or I can use temporary variable, another one, temp. You use temp here, and also we are going to use here previous. For that I will tell you why I am using this type of the pointer of structure type. So what is the idea that we are going to create, how many nodes we are going to create here? 5 nodes. For creating the 5 nodes, what we have to do that? Each and every time we should assign the now right here PTR is equal to head of next, because we are going to just to write PTR equal to head here, and what will do that? While we have to move the pointer here, so we are creating 5 nodes. How many nodes to be created here? Here create 5 nodes. You have to create the 5 nodes. So what is this idea? When you are creating the 5 nodes, we will use here, what is we are going to use here? I use the variable here temp, or PTR you can use, as I have already told. PTR equal to head, and for I equal to 1, how many nodes you have to create? 1. I less than equal to 4, and I plus plus, you have to do this. When you are doing that, for I equal to 1, use the block structure, for block. So what I am going to do that, each and every time you use a temporary node will be created here. Create the temp equal to, each and every time you create the node here, write the node star, and you write here it is malloc, and the size of, I will be explaining the structure how you define here for this. Okay, temp node. Now for this temp temp, what we are going to do, we are going to write here, we are allocating the memory here. Each and every time we will write a printf statement. What we will write here? We will write a printf statement. We will write a printf statement here. So how this is work here? So can I use the number of lines? So here I will write here printf enter node value, okay. So just you enter the node value here. You can write your scanf statement here, and you write here %d, and you write here, what is that you have to write here? You will write here head out. So our main objective is that in the temp we are creating that, you write here temp of the info. So what is this idea? After doing this part, we have created the new node here. Suppose we will do here after another. See this logic, how it is work. Let me, we have created, this is the temp node. We have created this temp node. Now what we are going to do that, we have to assign the address of this temp node once you have done it. So what is the idea that we should assign the what we are assigning here. So because we have assigned the PTR here, PTR of next we should assign the temp variable. Okay, and one thing that we have done here, you must write, once you allocate the memory, you write here temp next is equal to null. Temp equal to null. So this line I have specified here for clear understand. See that I will give the number accordingly how I am working. So PTR of next equal to temp here, and increment this loop will be goes. Now what is that idea? We have put it as PTR here, and we assign the address of temp into the PTR of next here, and process goes on. How the process will goes on? Next time I will be 2 here, enter the node value. First of all you enter the node value here, later it is called 10. Second time when it is goes inside the loop here, I will be 2 here, and again another new node will be created. Again another new node will be created here, and let this is the name here, temp here. And what I have to do here, once again enter the value here, and temp of this null equal to null, I specified here. Then I write the value here 20 and PTR of next. So what is PTR? We have to now move the PTR. Now it is the PTR here. Now I will write here PTR equal to PTR of next. So that is now this will become the PTR. In the very first step. In the first node, this operation will be performed. And close this curly braces here. For printf, enter the node value, scanf temp, PTR of temp, PTR equal to PTR of next. Assign this 20 value. Once PTR of next, now PTR of next will assign temp node here. So that is nothing but this link will be created. And next time, what you are doing that, you change this is to the PTR. Goes for this process again and again. What is the idea here? You create, now this is no more temp here, and this is going to create a temp node, make it is null, and what you have to do that, PTR of next, assign the temp value, do this operation, and what will do that, change this PTR, so to here, and there is no more use here, and you write here this is 30. Now loop is goes up to the 4 times, so you create another node which is called the temp, and put the null value here, and what you have to do that, PTR of next, assign this value. So as I already told you that this is x200, 2000, it is called 0x 3000, 0x 4000. This idea has given me a knowledge of creating the what? Knowledge of creating the linked list of this. Now what I am going to do in this particular concept, okay. Now line number, after doing this part, I have to go for the display. So if I display here, now go for the display the linked list. Display the linked list. If you are going to display the linked list, what is happened that we are going to display the linked list here. So I will call this module, display module here. What will pass here for calling this function? What I will do that? I will pass. Let me write PTR equal to head here, and I will write here display PTR of next. What will write here? I will pass PTR of next to this one. This is all about my display. How it will work I am telling you very shortly. Now let me go for insertion operation. So I'll write here insertion operation. This is the most important part of a linked list. Insert operations. How I am going to do this part? Suppose there are three situations or scenario where we have to insert the notes. Where we have to insert the notes? Print. Would you like to insert a note here? Right here. You will write here, within the loop we will write here. So first of all we will write a loop statement here. While true, we will write here inside this block here, printf insert at beginning, okay, or insert at the beginning, and this is the choice number 1. Printf /n to insert at end, and choice number 3, printf, here you write /n 3 is equal to in between. So what is this idea? In between. So now these choices will come. Enter your choice. By default, printf will write here, enter your choice. See, very interesting type of the creation. Enter your choice here. Scanf will write here the function called the scanf here. So we'll write here percentile t, and choice, for the choice what will do that, I will create the one of the variable here called the, as I told you that do not be worried about that what are the names we should declare here, but see that what are the names we are using. Not any predefined name, I am talking about the user defined names like this. An example, enter your choice. So choice is another type, integer type. I put it semicolon here. Scanf percentile and address of the choice. What will write that? I use a branch statement here, multi-branch statement for that. So what multi-branch statement I am going to use here? So switch. You will write here switch choice. I will be explaining shortly that case 1, it is for insertion. What you will do that insertion at the beginning? If I am going to insert at the beginning, you see that how it is going to be inserted at the beginning. Now you create a node here. Let me, you create a node here, right? So you can create a node here. So what is that here? Let me, I create a node here. I put it this name as called the temp. So you create the node first. So any operation you perform, insertion operation, insert at the beginning. If you want to insert at the beginning, you can insert. So if you are inserting at the beginning, suppose I write case choice here. So each and time we are going to insert an element. Why not you write a temporary, you can create a new node inside after this scanf statement. Right here, you write here equal to like this, temp equal to, what is that? Node star. I will be explaining the return type of the malloc. Why we are writing it is a as it is a pointer to the structure here. To write here size of node and bracket close here, and obviously temp of next. You should understand that, sir, why we are getting the next here, because in the one of the member is called this next here in the node structure, right? Temp of next equal to, what you will write here? You will write here null. So what I am going to do that, if I am choosing my first choice, So this temp node which is already created here, I should assign head of, what is that? I should assign the head of next which hold the address of the temp. Okay. Now let me cross this point of here of discussion here, because we are performing insert at beginning. Right. We are performing insertion at the beginning. So what we'll write here? Write here the head of next. Right here the head of next is equal to, we are assigning to the, this is the next node address, we should assign to the temp node. Temp of next. This is very vital to understand all that. So head of next should be assigned to the temp of next. Now I have already assigned in my temp. So that is that I have created this link here. Okay. I have created this link here. Now what I will do that? I will write here head of next is equal to temp. All about that. Similarly, break the loop. Case number 2. What we will do here? Now suppose we will go for the second insert at the end. What will do that for insertion? Here we may use here the previous pointer to structure type here. So for each time, what will do that? Write a previous here. Previous equal to head. So I will be using at the end. I must go to the end of the loop. And while, how will go to the end of the loop here? While previous, what is that idea? I will create one more node, one more variable here, that is called the PTR. What is that PTR here? Currently PTR equal to head of the next. PTR equal to previous of next. This is mandatory for defining. Now while PTR not equal to null, while PTR not equal to null, because I will be searching each and every time, what I will do that? I will insert the node, I will go back. So what will write in the block here? Write here PTR. First of all, each and every time I must assign the previous equal to PTR. Okay. Now this is my PTR and this is my previous. Previous equal to PTR. Now I am assigning previous equal to PTR. Now after this, write here previous here. And what will do that? Write PTR equal to PTR of next. Okay. So what will be happen that now PTR will come over here. Loop will be goes on. When PTR will be null, so sometime it will be, this will become the previous. Next time it will be PTR, and this will be previous, and I should change to this is my PTR. Now next time this will be previous and PTR equal to null. That is PTR equal to null. What will be happen that you come out of the loop and you have already previous node address. What you have to do that? Assign this previous of next is equal to temp. Right? After doing this part, what you are going to do is, this is over of that part, and break the loop. Break the switch statement, not the loop here. We have already break the loop here. Okay? Now third category is called case 3. What is that case 3? That insertion in between. So here I will give a number here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, okay, 18, 19, 20, 21, you see this? 21, 22, 23, 24, 25, 26. This end here. So you should very carefully observe that every block should be closed. The block is closed. 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. And coming to this point, while loop. Within the while loop we are there. 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 51, 52, 53, 54, 55, 50, 54, 55, 56. So this is the 56 here, right? 56. So we will continue the 56 line over here for refining this part. So line number 56 here. Let me go into this part. So switch statement, and the switch statement we are writing here, 56 part here. So I can continue this part here. 56. We are in the 56 part, right? 40, 41. Let it be there. 40, 41. Right. You have written that is right. 40, 41. Now 56. We can write this 56 here. 56 here. What is that 56 here? We will write here at in between any position we are going to insert. So there is a position. Suppose I will try to insert at the position 2. So print it. Case number 3. What is the case number 3? Print it. Enter the position. Enter the position. So scanf percentile D and here address of the position. So here one more name has come here. So right here it is called position. So what is that idea? Now line number 50, we can see here this is line number 57, line number 58. Continue this position, we are inserting to the position here. Suppose I will say that position equal to, I say the position equal to 3. So what I have to do that, position equal to 3. I will write here. So again loop will continue because already we have created a loop here. What we'll do that, we'll write here previous equal to head of the next. This is my, okay, write the head node, better to write your head node. And previous of head, what we have to do that, while, this is the loop position here. While, we have written the position, while position, while we are going to enter the position. Once you enter the position here, we have to use the position for loop, better for the use of for loop. For I equal to 1, I less than equal to position, goes up to the position. and you write here I plus plus. Now previous equal to the head node. Oh, okay. When I write this, better to write here head of the next node. So I got the very first node here. One the first node here, previous node. Now what is my idea? I equal to 1. What is position here? 1 is less than equal to 3. This is my previous node. Now what I am going to do that within the block here, right here, because 1 is less than equal to, yes it is true. Right here, previous, use the temporary variable. Here also we should assign temp equal to, what is the idea that? You have to create the temp equal to previous of next. Why you are doing that one? Better to write here temp equal to the previous. So because think carefully what you are going to do. Here we are writing previous equal to head of the next. Each and every time this is my previous node, we are checking. No. So what I have to do that? So I'll write previous equal to, you can write here this is my previous. So each and every time we have to keep tracks of the previous node. That is my objective here. So I should write here, this is, I should write here temp equal to head of the next. Also, you can write that, no problem in that. So what is this idea? I will write here previous equal to the temp. And I must proceed temp equal to temp of next. What will be happen in that situation? Bracket will be closed here. Loop will continue. When let's see how it is happening. I equal to 1. Yes. The first node is equal to previous. Assign this. Initially, this is also assigned as temp node. Both is assigned here. And assign the temp node. And here, this is the previous node. And temp equal to also, this is the node is also temp here. So we are assigning this previous equal to temp. Assigning previous. That is already defined here. Previous equal to temp. So what is the next time what we are going to do that? I will write here temp of the next node. So when temp equal to node here, I will be 2. Here I equal to 1. Here I equal to 2. And 2 is less than. 2 is less than 3. Equal to 3. Yes. So what is this idea? 2 is less than equal to 3. Yes. This will be, make it is a previous node. And right, this is my temp node. Now I will be getting incremented here. I equal to 3. And what is my idea? Idea is that I have to insert at the position 3. If you are going to insert at the position 3, what we have to do this? I have to, this is the temp node we have created in the temp of the next year. Now I equal to 3. Yes, this is my previous node. This is my previous node. So what happened that I have already jumped into another position of this one. So what is my idea? It is less than, just you write here it is less than. So what is this idea? 2 is equal to, if I write here 1 is less than 3, true. Here 2 is less than 3, it is true. 3 is less than 3, now it is false. So what is happened when I equal to 3 here? Now this is the false condition. Now it is the false condition. So it is not going to executed here. It will come out of the loop. It will come out of the loop. Now what is happened that here we have already preserved the previous node. Now we assign previous. Okay. We have the previous node. What I have to do that? I should write previous of next in my temp of the next. Yes or no? Temp of the next here. And once I assign this This is my new node to be created here. This is the new node we are creating. So this is my temp node. If this is my temp node, temp of next equal to previous of next year. Now what I have to do that, this link I should take from here and I must assign to this node. And already we have the previous node. Now write previous of next is equal to the temp node. And once this is over, finish up this part, write a break. Here, one of the things is that enter your choice, break the loop. And if any other choice default, it will be exit from the loop. 50, what is the line number we have specified here? 50, right here it is line number 59, 60, 61, 62, 63, 64, 65, 66, 65, 66, 67, 68, and already we have written break. Okay. 68, we have done this part. Now we will write here default. Any other, so it will be exit of the loop. So what is that idea? It will be exit, return from the program. You just write here, take a return. Okay? So it will be return of the loop from the default. Display the list. First we will display the list here. Default anything. Display the list here. How to display the list here? That each and every time we are inserting a node, even if you can write in every case statement also you define any choice. Suppose anybody inserting this one default, but why not you add a default statement or display statement in between this one? You can do that one. That is not necessary. You can write here display, and I write here head of the next. Let me display here and repeat again what I have written. Display head of next and return from the loop. You can write also exit or return, anything you can write here, not issue. And you close this switch statement and close this while loop. Once this statement is closed here, you write here, because any operation you perform, x equal to insert, you can see that while loop is working. Once this is over here, I can write here my last statement is called, everything is over here, write the return. If it is breaking from the loop, let it be break from the loop, it will be go to the loop again here, it will ask the choices. When it is break the loop, why not you write the display of the head of the next. Break the loop, better to write here, instead of writing here, you can write this display. This part you can write here, head of next. And this is not necessary. This is not necessary if it has come into that. Right? Let it be there, not issue that way. 68, 69, 70, 71, 72, 73, and it is 74. And last one is 75, is called return. Okay, return 0. And line number 76, end of main block. End of main block. Right. So it is the end of the main block. What is this idea? if it is the end of the main block, we have already written the display function, right? So 77, line number 77. So what we have to do that, line number 77. Line number 77, definition of display function. Which function? Display function. So what is that line number 78? Here void, we write here display, here write here node star, here it is temp or ptr, and open curly brace, line number 79, right here printf percentile, or you can write within this tab here, okay, slash t, percentile d, and you write here, okay, percentile d, double quote, and you write here ptr of info, right? And write here ptr equal to ptr of next, and line number 80, line number 81, line number 82, line number 83. What will write that? I think over this one. This is a very nice program, and I'll write the code here. I will show you the code, how exactly the way we have written all the statements, all the lines, same principle, all will be executed in the program. So I'm just attaching this one here.